we have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.
So you're curious about why NASA isn't moonwalking like in the good old Apollo days, right? Let me take you on a journey through the cosmic shifts in NASA's lunar exploration. Let's discuss what was learned during the moon missions which led to NASA not wanting to return to the moon. The Apollo program was a series of space missions undertaken by NASA with the goal of landing humans on the moon and returning them safely to Earth. This historic endeavor, while achieving groundbreaking successes, also faced significant challenges during its missions. Imagine this. Apollo 11, a mission straight out of science fiction, is on its way to make history by landing humans on the moon for the first time. But as Neil Armstrong and Buzz Aldrin, two astronauts braver than most, descend in their lunar module, things start going haywire. The onboard computer starts freaking out, flashing 1,202 inches and 1,201 inches alarms. Picture a computer so overwhelmed it's rebooting itself in the middle of a lunar landing. It turns out a simple radar switch was out of place, making the computer do extra work. Now here's where it gets wild. Mission Control, those geniuses back on Earth, quickly figure out that despite these scary alarms, the mission isn't doomed. But Armstrong, cool as a cucumber, sees they're headed toward a field of boulders. So what does he do? He takes manual control, steering away from danger and landing with less than 30 seconds of fuel left. Talk about a close call. Now let's talk about Apollo 12. These guys were aiming to land near the Surveyor 3 probe to do some next-level lunar science. But get this, just 36 seconds after launch, their Saturn V rocket gets hit by lightning. Yes, lightning in space. This zap knocks out their power and suddenly they're flying blind. But the crew, with nerves of steel, don't panic. With a bit of quick thinking, suggested by a flight controller named John Aaron, they flip a switch, SCE to AUX. Sounds like something out of a sci-fi movie, right? And just like that, they get their power and data back. The mission continues as planned, and they nail their lunar landing near Surveyor 3. Apollo 13, a mission that was literally an out-of-this-world roller coaster of events. It was supposed to be NASA's third time landing humans on the moon. The crew, James A. Lovell, John L. Swigert, and Fred W. Hayes, were all set for what was meant to be another historic space journey in 1970. But guess what? Space had other plans. 2 days after they launched, while they were cruising to the moon, something unbelievable happened. One of their oxygen tanks went kaboom. And it wasn't just any simple malfunction. An electrical fault turned it into a ticking time bomb. During a pre-launch test, someone had hooked up a heating element with too much juice, and it damaged the tank. When it exploded, it was like a scene from a sci-fi movie, but real. The explosion was so severe it knocked out their main power and heat source. Imagine being in the cold, vast space without heat and enough air. It was a nightmare scenario. But here's where it gets impressive. The crew, instead of panicking, coolly reported to Mission Control with the now iconic line, "Houston, we've had a problem." They then turned their lunar module, which was meant for moonwalking, into a life-saving lifeboat. Talk about being resourceful. Now, the spacecraft needed to get back to Earth, but it was on a lunar trajectory. So they did this incredible mid-space U-turn using the lunar module's engine. And think about this, they were living in a space meant for 2 guys for a couple of days, but now they had to stretch that for 4 days. They even had to jerry-rig a device to scrub carbon dioxide from the air using stuff they had on hand. It was like an episode of Space MacGyver. Despite being cold and conserving power like it was the last battery on Earth, they managed to power up the command module just in time for re-entry. And voila, they made a splashdown in the Pacific Ocean, safe and sound. Apollo 13 is more than just a space mission. It's a story of not giving up, of turning a potential disaster into a story of survival and quick wit. It showed how crucial it is to stay calm and work together when everything is going south. This mission, with its drama and nail-biting moments, has been told and retold in books and movies because, let's face it, it's the kind of stuff legends are made of. It's a reminder of the risks of space travel, but also of the incredible capabilities of humans when faced with the toughest challenges. Now let's explore the treasure trove of discoveries from those incredible moon landings and missions. It's like unraveling the secrets of an ancient cosmic time capsule. Starting with the Apollo missions, they literally kicked up some moon dust, called regolith, which is like the confetti of countless meteoroid parties over billions of years. And the rocks they brought back? Oh boy, they were a mixtape of lunar hits, basalts, and orthosites, all singing tales of the moon's complex geological past. We even found bits of the moon's highlands, the old timers, which showed us how the moon's crust first got its groove. But wait, there's more. Those Apollo missions were like cosmic detectives, setting up seismic experiments that listen to the moon's heartbeat or, well, moonquakes. These moon tunes helped us sketch out what's under the moon's surface, a crust, a mantle, and this tiny, partly molten core, quite different from Earth's big, lively core. Now get this, the story of how the moon was born. It's like a celestial drama. Lunar rocks whisper that the moon might have been born from this massive cosmic collision between Earth and a Mars-sized body. It's like Earth had a mega space crash and the moon was the result. And the moon's not some youngster either. It's about 4.5 billion years old, practically Earth's twin in age. But the plot thickens. Water on the moon? Yep, you heard that right. Initially, the Apollo guys didn't spot it, but later some brainy folks re-examined those lunar samples and bingo, signs of water. This was later confirmed by other missions, making us rethink our whole moon as a dry rock story. Now let's not forget the lunar program by the Soviet Union. They were the first to crash the far side of the moon's party with Lunar 3, showing us pictures of a landscape that's pretty different from the near side. More mysterious, more cratery. And the recent missions. They're like the new detectives on the lunar block. The Lunar Reconnaissance Orbiter and India's Chandrayaan-1 have been scoping out water ice in the moon's shadowy nooks. Crucial stuff if we're thinking of moonstays. Plus, the LRO's been mapping the moon like nobody's business, giving us the moon's version of Google Maps. But there's even more. The moon's got this super thin atmosphere, and the Lady mission was like a lunar environmentalist studying it, along with all the dust floating around. All these lunar escapades have taught us a ton about how planets get their act together, their history, and even about our own solar system's backstory. It's like the moon's been holding a diary of solar system secrets and we've just started reading it. And the tech. The challenges of playing detective on the moon have sparked all sorts of cool tech and science upgrades. Finally, let's get into reasons why NASA won't be returning to the moon. First off, NASA's got bigger fish to fry these days. Sure, the moon is cool, but now they're eyeing Mars and even deeper space. Think of the Artemis program as their new playground. They're planning to hang out on the moon, but really it's like a practice run for the big show on Mars. Now let's talk tech. The gadgets and gizmos they used during Apollo are, well, ancient history. Today's space tech is like something out of a sci-fi novel. This isn't just a change in toys, it's a whole new ballgame in terms of how they plan and execute these missions. It's like swapping a horse carriage for a sports car. Budgets, the eternal buzzkill. Space exploration costs a cosmic fortune, and NASA has to be smart about where they spend their cash. They've got a lot on their plate, from unmanned missions to hanging out on the International Space Station and even peeking into the depths of space. Here's where it gets interesting. Space is no longer just a NASA show. It's like a cosmic United Nations up there, with the European Space Agency, Russia's Roscosmos, and others all joining the party. Oh, and let's not forget the new kids on the block, private space companies like SpaceX and Blue Origin, shaking things up. The moon's been under NASA's microscope since Apollo, and they've learned a ton. But now they're casting their gaze further, Mars, asteroids, the outer planets. It's like they've read the moon's diary, and are now curious about the diaries of its celestial buddies. Safety's a big deal too. Space is as unforgiving as it gets, and after some heartbreaking losses like the Space Shuttle Challenger and Columbia, NASA's not taking any chances. This means they're super cautious about how they send humans into space now. Sustainability's the new buzzword. NASA's working on this cool thing called the Lunar Gateway, a space station that's going to orbit the moon. It's like a pit stop for astronauts, making it easier to come and go from the lunar surface, and maybe even hop over to Mars someday.
It really is.
Oh, geez, that's great. Is the lighting halfway decent?
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface.
Was there ever a moment on the moon where either one of you were just a little bit spellbound by what was going on?
About 2.5 hours.
Once upon a time, nearly 4.5 billion years ago, our solar system was a place of chaos and creation. Amongst the swirling debris and cosmic dance, a story unfolded. The birth of Earth's moon, a tale not of gentle beginnings, but of cataclysmic collisions.
Is called the giant impact theory. The theory states that a Mars-sized body struck the young Earth, and the moon formed from the debris disk around the planet.
In this cosmic ballet, Earth was young and unrecognizable, a burgeoning planet in the vastness of space. The stage was set for a dramatic event, one that would shape the destiny of our planet and give rise to our beloved moon. The key player in this story was Theia, named after a mythical Greek titan. Theia wasn't just any cosmic entity, it was massive, almost the size of Mars, and it was on a collision course with Earth. Imagine the unimaginable. Theia, with its immense size and speed, crashed into Earth with such force that it was more than just a mere impact. It was an event of cosmic proportions, a spectacle of destruction and creation intertwined. The collision was so intense that it tore chunks off our planet, sending a maelstrom of molten rock and vaporized debris hurtling into the space around Earth. From this chaos, something remarkable happened. The debris, the remnants of this violent encounter, didn't just drift away into space. Instead, they began a dance of their own, swirling and coalescing under the force of gravity. Over time, this cosmic debris, born of fire and fury, came together to form a new celestial body, our moon.
The Earth and the moon are actually like identical twins. That means that the Earth and moon are made from the same materials.
This story of the moon's birth was not always known. For a long time, humans gazed at the moon, weaving tales and myths, wondering about its origins. It was not until the late 1960s and early 1970s, with the Apollo missions, that our understanding of the moon's true origins was revolutionized. Astronauts journeyed to the moon, not just as explorers, but as detectives of the cosmos.
You're now national heroes. What are your initial feelings about being heroes?
Probably get an answer to that question. Might have to spend as long preparing as we had to prepare for Apollo 11.
They returned with precious cargo, lunar samples, weighing a total of 842 pounds. These rocks were silent witnesses to the moon's fiery birth. They revealed secrets that previous theories couldn't unveil. The rocks showed signs of having been part of a molten world, an ocean of magma, which pointed to an origin story of great energy and impact. They were like pieces of a puzzle, fitting perfectly into the theory of a massive collision leading to the moon's creation. In the grand tale of the moon's origins, the evidence gathered from the moon itself plays a starring role, revealing a story of unity and separation between the Earth and its satellite. The clues were hidden in the very rocks of the moon, waiting to be uncovered. When astronauts from the Apollo missions brought back samples of the moon's basaltic rocks, scientists made a fascinating discovery. These rocks, formed deep within the moon's mantle, bore a striking resemblance to the basaltic rocks from Earth's own mantle. It was like finding pieces from two different puzzles that matched perfectly. But it wasn't just the rock's appearance that was similar. It went deeper than that. The oxygen isotopes and other elements within these rocks were almost identical to those in Earth rocks. This was no coincidence.
The genetic code of planets is written in the isotopes of the elements. All of the planets are made from different materials, so they all have different isotopes. They all have their own genetic code.
It was a clear sign that the moon and Earth were once part of the same whole. But the story doesn't end there. Meteorites added another layer of evidence. The lunar meteorites, unlike the samples collected by the Apollo astronauts from a few specific sites, provided a broader perspective. These space-traveling rocks, flung from various locations on the moon and eventually landing on Earth, echoed the same historical account of the moon's origins. Moreover, meteorites originating from asteroids served as cosmic timestamps, helping confirm the timeline of the moon's dramatic formation. The plot thickens with more recent studies. Scientists, like detectives with a magnifying glass, analyzed the light reflecting off the moon's surface. What they found was telling. The surface was abundant in anorthosite, a type of igneous rock that forms and floats atop a sea of magma. This discovery was crucial. It suggested that the moon, in its infancy, was not a solid sphere, but a celestial body enveloped in a deep, extensive ocean of molten rock. This magma ocean, potentially hundreds to thousands of kilometers deep, was a testament to the high-energy impact that birthed the moon. This compilation of evidence from lunar rocks, meteorites, and surface analysis weaves a compelling narrative. It tells of a past marked by a cataclysmic event, powerful enough to break off a part of Earth and create a new entity in space. The moon, as we see it today, serene and unchanging in the night sky, carries the scars of its turbulent beginnings, a mute reminder of its shared history with Earth. In the vast expanse of space, the moon hangs like a silent witness to the ancient history of our solar system. This celestial body, so familiar and yet so mysterious, holds within its craters and plains the secrets of a past event of cosmic significance. The story of the moon is not just a tale of its existence, but a narrative of lunar archaeology, where scientists, much like detectives, unravel the mysteries of its formation and evolution. The moon, compared to Earth, is like an untouched crime scene. Earth, with its restless geological activities, erases its own tracks of formation over time. Plate tectonics shift, mountains rise and fall, and erosion smooths away the past. But the moon is different. Its surface changes at a glacial pace, preserving the evidence of its birth. This stark contrast makes the moon an invaluable source for understanding the early history of our solar system. It's as if the moon has been waiting billions of years for us to read its story. One of the most intriguing aspects of this lunar story is the moon's composition, particularly its low iron content. Earth, with a heart of iron that makes up about 30% of its mass, stands in contrast to the moon, whose core is a mere fraction of its total mass. How did this come to be? The answer might lie in the violence of their shared birth. The colossal impact that is believed to have formed the moon might have vaporized lighter materials, casting them into space, while heavier elements like iron remained with Earth. But the moon's tale is not just about what it's made of. It's also about where it is and how it moves. The moon is slowly drifting away from Earth, about 1.5 inches each year. This gradual journey speaks of a past where the moon was much closer to Earth, suggesting a time when Earth spun faster on its axis. The dance of Earth and moon, through billions of years, shaped by gravity and tides, is a complex ballet that any theory of lunar formation must account for. The plot thickens when we consider the moon's two faces, the near side and the far side, each with its own unique characteristics. The near side, with its thinner crust and history rich in volcanic activity, is markedly different from the far side's thicker crust and quiet volcanic past. These differences raise questions about the moon's cooling process, its volcanic history, and how it has been shaped by the impacts of space objects. In the quest to unravel the moon's ancient secrets, scientists stand on the cusp of a new era of discovery. With humanity poised to return to the moon through the ambitious Artemis program, the anticipation is palpable. This upcoming journey isn't just a leap for space exploration. It's a gateway to a treasure trove of information that could finally answer the lingering questions about the moon's formation. For now, scientists make do with what they have: lunar samples from past missions, data from orbiters, and a growing understanding of planetary formation. These pieces of the puzzle are being meticulously analyzed, helping to build sophisticated computer models. These models are like digital time machines, allowing scientists to recreate the colossal collision that birthed the moon and Earth as we know them. They take into account various factors like the strength and density of the colliding bodies and how materials behave under extreme conditions. It's a virtual cosmos where scientists can tweak variables and observe the myriad outcomes, each one offering a glimpse into a possible past. The models are not perfect, unable to simulate every atom in such a massive event, but they offer a window into understanding how even minor changes in the conditions could lead to vastly different outcomes. The true power of these models lies in their ability to evolve with new evidence. Each piece of data, each new discovery refines these virtual scenarios, inching closer to a comprehensive model that encapsulates everything we know about the moon. The Artemis missions promise to be a turning point in this lunar detective story. Since the last Apollo mission in 1972, Scientists have had decades to study the samples and data, but these have limitations. The Apollo missions explored regions near the Moon's equator, primarily volcanic areas. The new missions aim to cast a wider net, targeting diverse locations like the far side of the Moon and the poles. By drilling down and extracting core samples, scientists hope to uncover more layers of the Moon's geological history, each layer a chapter in the Moon's epic tale. These new samples and data will help refine the models, eliminate certain scenarios, and narrow down the possibilities. It's a cosmic game of Clue, where each new piece of evidence rules out certain theories and brings others into sharper focus. But there's always the thrilling potential for surprise, new discoveries that could turn our current understanding on its head. The Moon, with its silent craters and ancient plains, may still hold its greatest secrets, waiting just beneath the surface for the curious hands of humanity to unearth them.